Two-variable distributions, or bivariate data. While univariate data is used to describe scenarios, objects, or categories, bivariate data uses two variables or two types of data to compare and analyze causes or relationships for the purpose of explanation. Bi means two, and variate means variable. Using the student score example from the previous lesson on univariate data, we can turn it into bivariate data by adding another type of variable. For example, is there a relationship between grade scores and the number of hours spent studying per week? In the previous univariate data video, the bar graph of the 11 student scores had both categorical data, the students, and numerical data, the scores. Bivariate data may compare two numerical sets of data, two categorical sets of data, or both a numerical and a categorical set of data. When two sets of data have a relationship, one set will be independent and the other will be dependent. In the case of the scores and hours spent studying, the scores are dependent on the hours spent studying, so scores are dependent and hours studying are independent. Another word for numerical data is quantitative, and when both sets of data are numerical, as in the example of student scores and hours spent studying, the presentation is most often in the form of a scatter plot, which can graph the two variables. In a scatter plot, the dependent variables are measured along the vertical line or y-axis, and the independent values are measured along the horizontal line or x-axis. The following is the data for student scores and hours spent studying per week. When the data is entered into a scatter plot, it looks like this. When the independent and dependent values increase together, that is called a positive correlation. In this example, there is a positive correlation between the independent variable, or number of hours spent studying per week, and the dependent variable, or the grade scores. In other words, higher study hours tended to result in higher scores. If the independent and dependent values move in opposite directions, that is called a negative correlation. Comparing the same scores to the number of hours spent playing per week, we can see an example of a negative correlation in which the two variables move in opposite directions. As the independent variable or play hours increase, the dependent variable or scores decrease. How do we show a positive or negative trend? Scatter plots use a line of best fit, which is a line drawn through the center of the points, and this best represents a direction. The line of best fit can also show us more information about the correlation or relationship between the two variables based on strength, numerical value, and direction, positive or negative. The closer the points are to the line of best fit, the more correlation, or the better the relationship between the variables. If the points are far away from the line of best fit, if the line of best fit is vertical or horizontal, or if you can't draw a line of best fit at all, there may be no correlation between the data sets. If there is no relationship between the numbers, then there is no correlation between the data sets. Bivariate relationships are measured by their strength and the difference between the independent and dependent variables. Types of variables determine the type of graph used. Graphical depictions are part of statistical analysis. In summary, bivariate data is a way to show relationships between variables. If there is a relationship between two data sets, then one will tend to influence the other. Bivariate data analysis is a way to determine if there is a relationship, the influence of one variable to another, and the level of influence from one variable to another.